welcome everyone. So we are here to talk to you about Chainlink and how to build cross-chain applications with Chainlink CCIP. I am Sol, and these are my networks, and feel free to follow me and discover what we are doing, what we will do in the future. And I came from Brazil, and
yeah, my name is Andrej. This is my Twitter. I tweet around about Chainlink, Solidity, Rust sometimes. And this is my newsletter. I started writing it pretty soon. It's called Smart Contract Design Patterns. It's about smart contract design patterns. So if that's interesting to you, you can sign up.
Yeah, so let's go. We are starting talking about our abouties. Probably you saw it before, but you can choose two different tracks. One is to use CCIP, and the three best projects can win 2,000 each, or you can use the other Chainlink services and win 2,000 each. We have two bounds on this, and maybe you are using more than one Chainlink services and you can win both of these. It's possible. And this is the most important care code for you. So if you'd like to read this, then I know that I have more care codes in the middle, but it's everything that you need to this hackathon. Yes, almost done. Okay, so let's go. And would like to talk about oracles. What is that oracle?
Yeah, sure. So essentially, Oracle is by design any off-chain component that can provide off-chain data and computation. So oracles essentially connect real world with your smart contracts, and Chainlink is a platform for Oracle services. We have a bunch of Oracle services, but essentially you have some kind of data sources and external resources, and you can easily connect those with your smart contract, whatever that is, and then perform some computation on-chain.
Perfect. And the best related to oracles, it's so important that Oracle have a decentralized Oracle network, because the way that you are bringing the information inside the blockchain is the key. So even if the information came from only one source, you can have a consensus to save this information inside your smart contract. And let's talk about a bit about the Chainlink service itself. So we have some services related to data. Would you like to talk about that, Andrej?
Yeah, sure. So if you've been following Chainlink for a while or been in this space, you'll probably say that Chainlink is an Oracle service that provides price data. But in the same way, internet is just for email or Amazon is just for books, Chainlink is just for price feeds. So we have like much more services than just price feeds. Like price feeds are just a subset of data feeds, which can be like rate and volatility feeds, NFT floor price feeds, all that other stuff. So yeah, all of these services you can get using Chainlink, and you will be eligible for a hackathon bounties if you use any of these. And obviously we're here to help you.
So the other services that are not related to data, for example, VRF can be used to generate random numbers. Also, you can use automation to call any function inside your smart contract with the rules that you can define. Like you can define the conditions, or can be called by 1 day or 1 hour or 1 minute, or even related to some log. If that log appear, you emit that event, then you can have some function be executed. And also talking about functions itself, we have the Chainlink functions that you can call any external API. Even if you have secrets, you are writing a JavaScript code inside your smart contract, and then calling that information and having this information inside your smart contract as well. And remember that we are not a blockchain, we are agnostic, and we are deployed, our services are deployed in many blockchains. And what's CCIP?
Yeah, sure. So we have a specific bounty for CCIP, and we want to spend some time talking about the CCIP. So this is the high-level architecture of CCIP, and that's pretty much it, what you need to know about CCIP, at least for this hackathon. So there is a router contract, so CCP router contract, one router contract per CCP-powered blockchain, and that router contract actually handles incoming messages. So if you want to send a message, cross-chain message, that can be tokens, data, or both, like programmable token transfers, where you can transfer both tokens alongside some data, then you can just call the CCP send function of the router contract, and that's it. Pay for fees and Similarly, how you can send a package using UPS or FedEx, whatever, you just pay, give them the package, and they will handle the rest, even if it's like a overseas flight or whatever. That's why, if you go back to the previous slide, please, you can see that in the middle we have a CCIP, which is kind of like a black box, and in the documentation there is like a broader architecture of it if you want to take a look at it. But essentially, you just outsource your transfer of messages to the CCIP, and then the router contract on the other side will deliver the message eventually. And we have Explorer to track this message transfer in real time, and that's pretty much it, what you need to know for CCIP. So this is probably the most important slide for you. Just understand it like this, and that's it.
So, and I'm doing a demonstration for you now. So I'm transfer USDC from Avalanche Fuji to Ethereum Sepolia. I'm using Avalanche Fuji because between the test nets, this will be the fastest to do here. The other one, maybe I cannot do like in 5 minutes. And these are all the requirements to do that. You have the slides, the presentation, so you have all of this. You can do this done after. Also, I'm using USDC from Circle. So here is the Circle faucet and the way that you must get the address and add it to your wallet as well. And this is the content that I'm using now. You have this. And it's time to do it. So I deployed the content like 1 minute ago, but maybe I can deploy again and show both to you. So this I made 1 minute ago, and I'm doing another one just now. So I'm here, and I'd like to deploy. And probably my MetaMask is locked or no. Let's see. It's everything right here. Should deploy. It's interesting when you are live and the things didn't work. Oh, yes, it's a bit slow, only this. Okay, so we are ready. Great. So I'm deploying a new version of this. If I scroll down, let's see what's happened with my content meanwhile. I'm importing the router. So my content is communicating with the router that we showed a few minutes ago. And also I have the client to have the structures that I need to send the message. I did one, so I reject that. I have all related to ERC20 token, also to interact with this. And then here I may handle the errors here. And I'm initializing this, and in the comments you can use another chain as well, because I put the way I got the chain. So this is the router that I'm interacting with. This is the link, because I decided to pay the fees using link. And Andrej, where I'm paying the fees? I'm paying the source destination. What's happened?
Yeah, sure. So you'll just need to pay for fees on the source chain whenever you send the message. Can be paid in link, can be also paid in native coin. So you're just going to use message.value if you need, or you can use the wrapped implementation of that native coin. So that, for example, on Ethereum Sepolia, you can use wrapped ETH as well to pay for fees. And essentially, you're just paying the off-chain dons to transfer the message on the other side. And that's it. Like, you just pay for once, no spinning up any off-chain components or nothing. Simple as that, really.
Perfect. And I'm doing this using USDC. So here I have the USDC address, the token that I'm sending. And I'm going to Sepolia. This is the destination chain selector. This is for Sepolia. And you can find all of this here that I have over there on my content as well. So we are going from Fuji. This is the router. This is the link token. I'm going to Sepolia, so this is the destination chain selector. Everything is in our documentation. And okay, this is the event. When I do that, I'm initializing everything, and this is the most important function, that is the transfer. I'm doing this first, and then I can explain this part for you. So, okay, I deployed the content. Where is my content? I think it's here. This was just now. I must do two things now. First, I'd like to have some link inside my content to pay the fees. Let's do that. So I'm here. I'm going to tokens, link, send. For my smart contract address, I'm sending like 2 or 3. Yes, it's a bit slow here. It was better when I was not on the normal.
Yeah, what she's doing now, like her contract assumes that links are part of the contract itself. So she's funding basically her contract. But you can also just save transfer from inside a send function if you don't want to have it like this. So you're completely flexible when paying for fees, just FYI.
Exactly. You can see over there, like if I go to my transfer function now, you can see that first I'm creating a structure, in fact is an array that I could even transfer more than one token. For each token, I must say the address of the token and the amount that I'm sending. Then that array of tokens will be here in the message. This is the struct of a message that we have in the client of CCIP. So the receiver can be any account because it's only tokens. If it is like messages as well, external account cannot receive a message. So for this must be tokens. And any data, I could, for example, send the token and send a message. What I'd like to do with the token on the other side? I'd like to stake, I'd like to do a swap. I could do everything or anything here, defining the data part. And this is the token amounts that we said before. And I don't need to have any extra argument here, but for example, if I'm minting an NFT, I'm calling the mint function in the other blockchain, I must increase the gas limit. And here I'm telling that I'm paying the fees using the link token. Okay? And let's see what's happened here. It is still waiting. Yeah, I'm so glad that I did this before because at least I have one done to show you. And come back here, you can see that the router is calculating the fee to us. So I am in the Cersei blockchain and the router is going to the destination blockchain and getting the right fee related to the size of my message. And here I can know how much I must spend in the Cersei blockchain. And I'm also checking if I have enough link on my contract to pay that. Another point that's important, I'm sending USDC. So I'd like to be sure that I have enough USDC on my account. So the USDC is not on smart contract, it's on my personal account, my external account. And this is the second part that I must do. Like I must approve this contract to use my USDC. So I came to the Explorer in the address of the USDC here. And this is the address of my contract now, the new one that I just deployed. And I'd like to approve to use one USDC. Is one in 6 zeros because we have 6 decimal places in some place here. Let's do it. So I'm approving the contract now. After that, the contract will be able to get the USDC in my external account and send to the other blockchain. Yes, it's really slow now. Okay, next approve. Okay, this is what you are saying here. I'm checking the amount and transferring the amount from my external account to the contract, then approving the contract to send it to the other blockchain using the router. And after everything is checked and everything is good, then we have the CCIP router sending the message to the destination chain selector. Okay, we are almost in that point. Let's see if it's confirmed. Yes. So if I go here now, I can use it. This is the last one. I can transfer. So I'd like to transfer to my same account or no. I'd like to send to another account. And come back to the other because I only got the address. So I'm sending to another account and it's the same, 1 and 6 zeros. The decimal places. I'm sending from Avalanche Fuji to Ethereum Sepolia. I click on transact. After I approve that, we are explaining more with a kind of overview of the other parts as well. So I think we are only waiting now. Okay, we are waiting. So let's go to the presentation a bit more and understand this part. So Andrej, what about you to tell them what is happening now?
Yeah, sure. So I'll try to do it quickly because we're running out of time. So this is the broader architecture from that previous slide. So we can see here that she is interacting with the router contract on the left, calling the CCP send function. And now we are basically have 3 off-chain components. Committing down is listening for the events from on-ramp contract, which will interact with the token pools if you're sending tokens, which is happening under the hood. Then it will post a report of that batch of messages on the other side to the commit store contract, which you cannot see on this screen, unfortunately. And then risk management network will do the same thing and also vote on that batch of messages. So it can be either cursed or blessed. If blessed, that's good. That's what we want. When we see a blessed signal, the executing done will interact with the off-ramp contract to mint or unlock the appropriate, the same amount of tokens on the other side, and then the router will just deliver the message. So that means for you, if you want to limit who can call your CCP receive function, you can put a modifier to say that only router can call it, and that's pretty much it.
Yes, amazing. Let's see what's happened on practical, because I already sent the transaction. If I got the ID of my transaction and came to the CCIP Explorer, probably the search is already finalized, and we are in the moment that we are blessed, maybe, let's see, I don't know. Maybe it was fast. It's looking for my transaction now. Okay, so it's been like, we have, yes, now yes. Okay, we have the search finalized, and we have 2 minutes here to wait. Meanwhile, we are waiting, so let's come back here and talk about, okay, I'm waiting, but we are in a hackathon, we must do everything so fast, and you don't have time to wait, so use the local simulator.
Yeah, sure. So if you go to our GitHub, Chainlink-local is the CCP local simulator. So instead of building directly on testnets, we can see now that we are waiting for transaction to complete on a testnet. But imagine that you have a bug or a flaw or something in your smart contract. Then you will need to redeploy, deal with gas, with faucets, with tokens, with all that stuff. With Chainlink local, you can literally build locally in Hardhat, Foundry, or Remix, whatever your development choice is, and once you're ready to move to testnets, then you can easily move to testnets, and we have a brand new faucet for that, where you can get multiple different tokens, from multiple different blockchains to multiple different receivers on the same request, which is pretty cool, pretty powerful.
Yes, and this is the multi-chain multi-faucet.
Yeah, looks like this. So just select, I want this amount of token from this chain, that chain, these receivers, hit request, and that's pretty much it. You're ready to move to.
So why CCIP is your interoperability protocol? So you have this local simulator, this new faucet multi-chain, you don't need to run any kind of off-chain infrastructure, and you can send the message and the tokens in the same time. So we can have this kind of programmable token transfers. And remember about our bounties again, to wrap up, you can use this with Ethereum, Arbitrum, Basis, Celo, and Polygon. They are here as well. They are sponsoring, and maybe you can win both bounties because using them and using us. And only to finish, let's go to the presentation. If you didn't get the presentation yet, you can get it now.
And yeah, if you have any questions or anything, we'll be around here or at the booth because we're out of time. Sorry.
Okay. And this is done. Let's see. Finish.
That's it.
Yes.
Thank you, guys.
Thank you.